So let's start now with the module 2. Okay. So for the module 2, we have a total of 56 slides. So I hope, yeah, again, we can finish this one in just 1 hour and 30 minutes. But yeah, so we're going to talk about the language of sets and the language of relations and functions. Okay, so someone chatted? No, so someone is asking, sir, meron po bang GC sa Math 100? No, that depends to you guys. If you guys would like, to create a GC group chat and then you can add all of your classmates. Well, mostly kasi hindi sinasama instructor. Okay. So yung announcement ko, lahat nasa Canvas. I don't announce things in GC. Okay. Very kasi informal, and one more thing, pinagbawal kasi hindi kami mamomonitor ng mga nagche-check nung nasa Canvas namin. Okay, so it would better if we'll announce everything in Canvas. So if you guys would like to create your own Canvas, okay, as long as you're going to help each other, not going to, let the others cheat on your work or para lang makakopya kayo, then that is a no-no. Okay, so mas maganda pang ma-zero kayo and then matuto kayo on your own kaysa naman nangongopya lang kayo. Okay. All right. So yeah. Okay. So let's start with the question. So what is a set? Well, I'm pretty sure that you guys already know what is the meaning of a set, but in mathematics, so we call this one a formal mathematical term. Okay, wherein, of course, if it's a set, there is a collection of elements below it. Like for example, C is the set of all countries in Asia. Then Philippines is an element of C. Okay. So this C is like the title, and then below that are all of the countries in Asia. Okay, and then one element of it is Philippines or Japan or China or Korea. Okay, so any country that is under Asia, okay, is an element of C. Okay, so this C could be changed into any letter. Okay, so it could be countries in Asia, but mostly when we say set, it's just being represented by one letter. So I think C is the perfect one, but this could be A, this could be B, this could be M. So any letter that you want. Okay, another example is I is the set of all integers from 1 to 100. Okay, then the number 26 is an element of I. So it's very straightforward. Again, I is like the title, and then below that is the elements where it's ranging from 1 to 100. Okay, so one element of that one is of course 26. And then how about 101? Okay, so can we say 101 is an element of I?
No, sir.
Of course not, right? So a set also has a limitation, okay? But a set could be finite also. So sometimes it doesn't have a limit, but mostly it has a boundary or a limit, just like this one, from 1 to 100 only, and specifically integers only, no decimals, okay? The next one that I would like you guys to know is notation. So in Math 100, we always have this notation wherein if S is a set, the notation of X, whatever we call this one, means S means that X is an element of S. Okay, so I forgot the Greek name of this one, but this one symbolizes the word element. Okay, so if you're going to read this one, X is an element of S. Okay, so this is the set S, and then X is just an element. So the notation, supposedly it should be something like this also, but I cannot find like a letter E, okay, that has like an overline. Okay, so if I'm going to draw that one in a whiteboard or a blackboard, so it should be, pangit naman yan, should be something like this. So this one represents not an element, okay? Or this one is also the same with like this, or ganyan. This one is the same with this one. So this one is also not an element, okay? So if it's just E, means that it is an element of that something, okay? But this one is not an element of S, okay? So for example, we have this let E. this is the set A, which contains element of 1, 2, 3, and then set B, which contains the element of 3, 1, 2, and then set C, which contains an element of 1, 1, 2, 3, 3, 3. So here's the question: what are their common elements? Anyone who would like to answer? Okay, coming from Mr. C and De La Cruz, it's 1, 2, 3. Okay, very good. Most of you get the correct answer. So the answer is 1, 2, 3. Okay, so let's have another example. Is this one equal to this? Anyone? So is this true or false? Are they equal with each other or no? Okay, coming from Mr. Rexor and Mr. Ann, so they said no or false. So you guys are actually correct. So 0 is not equal to 0, okay, or this 1 is actually a set, okay, which contains an element 0, okay, and then this is just a 0. So they are not equal because this 1 is a set with one element which contains 0 as your element, and it's namely 0, whereas 0 is just the symbol that represents the number 0. So if we are going to draw this one, because we can actually draw this one using, you know, a figure. So once you guys have saw something like this, and then it's containing an element. So let's just say 0. So this curly bracket right here can be represented as a box. Okay, so this is a set of anything. Okay, so this one contains an element 0. Okay, wherein the other one is just 0. Okay, so as you guys can see, they are not equal because this is a set with an element 0, and then this is just a number 0. Okay, so let's have another example. So how many elements are there in the set of this one? So when trying to answer, okay, so don't try to cheat, okay, because I know that you guys can already access the PDF of this one, okay, because I've already uploaded the entire PDF. But yeah, let's try to answer this one on your own without looking on the next slide. So coming from Mr. Plexor, 2. What about the others? Do you guys have the same assumption or answer? So someone has an answer of 1. Most of you are 2. Okay. So the correct answer is actually 2. Okay. So this one, the set, whatever you read this one, has 2 elements. 1 and the set whose only element is 1. So if we are going to draw this one using a box, so we have 1 and then okay. So the outer curly bracket is already the box itself, okay, which is already a set. And then this one is just 1, okay, that's already one element. And then we have another box since this is also a curly bracket. So sorry for my ugly drawing. Okay, and then this one contains an element 1. Okay, so regardless of how many brackets do we have in here, let's say we have 2 or we have 3, so it's just have another box and then box in it. Okay, but this one is counted as one element. Okay, so we only consider the outer or the first box, the outer box, and then we count this one as 1 and then another 1. Okay, so a total of 2 elements. Okay, so 1 and the set whose only element is 1. Okay, has 2 elements. Okay, so let's have another example. So in here, it's now in a like call this one language of sets. This is not the formal language of sets. So for each non-negative integer n, let u sub n is equal to n. Okay, so it's a positive n, and then we have negative n. So it's asking us to find u sub 1, u sub 2, and u sub 0. So this one is super easy. Anyone who would like to answer? The u sub 1, what is u sub 1 and u sub 2 and u sub 0? Okay, just answer u sub 1 for now. What are your answers in u sub 1? So u sub 1 coming from Mr. Sian, so it's 1 and negative 1. Yeah, that's correct. So we have a total of how many elements in u sub 1? So we have 2 elements, right? Okay, great. How about u sub 2? What is the answer in u sub 2? Okay, so it's 2 and negative 2. So that's also correct. Okay, and then how many elements do we have in u sub 2? So there were also 2. Very good. How about the last one, u sub 0? Okay, what is the answer in u sub 0? Okay, so 0 and negative 0. So, okay, the answer of Mr. Sian is quite acceptable, but to make it exact, that is actually incorrect. Okay, the correct answer is the one that is came from Mr. Christian and then Mr. J. Luis. Okay, so in a set, there must be no repeated elements. Okay, so take note on that one. So that is why in here, we have 1, 1, 2, 3, 3, 3. Okay, so we have 3 repeated 3s. So you can just simply remove the other 3. Okay, and you can simply remove the other 1. Okay, and then as a result, we have 1, 2, and 3 in here. Okay, and then one more thing that you guys need to remember in a set, arrangement doesn't matter. Okay, so 1, 2, 3, 3, 1, 2, 3, 2, 1, they are just the same. Okay, so arrangement doesn't matter, and then the existence of duplicate elements is prohibited in set. Okay, so all of them must be distinct with each other. Okay, so where are we now? So here are the answers. So u sub 1 is 1 and negative 1, u sub 2 is 2 and negative 2, and then u sub 0 is 0 and negative 0. We're in, if we're going to simplify this one, so we don't have negative 0 actually, so this will just become a 0. Okay, so let's have another example. So let x is equal to abc, y is equal to acb, and excuse me, z is equal to abb, cc, cc. And what are the elements of x, y, and z? So let's answer this one first. What are the elements of x, y, and z? Okay, very good. So it's just actually ABC. Well, to give you the correct process, what we will do is lang tayo. Okay, so what we can do, so let's just say that we're going to add all of those sets. Okay, so in here we're going to have A, B, C, okay, followed by the elements of Y, A, C, B, followed by the elements of Z, okay, which is A, B, B, C, 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 C. So this is actually the first assumption, because it's asking us all of the elements of X, Y, and Z. Okay, but then again, since we are talking about sets, so we have to remove the duplicates. Okay, and then as you guys can see, we only have three distinct elements, which are the A, B, and C, and then the rest, they are just simply duplicate. So as a result, A, B, C are our elements. Okay, and how are X, Y, and Z related to each other? I think this is super easy already once I've already answered the first question. Guys, instead of typing, I think it would be better if you guys will just talk, will just speak to the faster. Okay, well, anyway, if you guys are quite shy, so yeah, they have common elements, or all have ABC as element, and they have all elements in common such as ABC. So your answer in letter A, most of you got the correct answer in letter A. Okay. Okay, how about letter B? So let's now proceed to the second one. How many elements are in the set A? And this one and this one. Okay, so very good. I hope you guys have now got the idea about sets. So we only have 3 elements in here. Okay, how about the last one? For each positive integer x, let a sub x is equal to x and then x squared. Find a sub 1, a sub 2, and then a sub 3. So who would like to answer a sub 1 first? Okay, so the answer of Mr. Rexor is incorrect. First, because it doesn't have a curly bracket, so it's not a set. Okay, and then it has a double one. Okay, and again in a set, we remove the duplicate. So the correct answer, the most complete answer is the answer of Mr. J. Luis Calictan. Okay, very good. So the answer on a sub 1 is this curly bracket? Yeah. So it must be curly bracket and then 1. Okay. What about 2? A sub 2 rather. Yeah, 2 and 4. Okay, very good. How about A sub 3? 3 and 9. Okay, very good. So here are the answers for those examples. Okay, so here are the question. I mean the answer for the first question, and then here is the second answer for the second question, and then the answer for the letter B, and here are the answers for the A sub 1, A sub 2, and then A sub 3. Okay. So let's talk about now special symbolic names. So R stands for the set of all real number, and then Z is a set of all integers, and then Q is a set of all rational numbers or quotients of integers. Okay, so if you guys are get confused on what is this real number, what is this integers, what is this rational numbers, so I have prepared this one, came from the internet. So this one is super perfect, when it comes to real numbers. Well, to make it exact, real number is any number that you can think of that exists in the entire universe that we are using on our daily life. So it could be irrational numbers, could be integers, could be whole numbers, or it could be natural numbers. Okay, so all of those are real numbers. Okay, and then integers are of course whole numbers, okay, including the negative and then the 0. Okay, and then for the quotient, okay, so we have this rational numbers. Okay, so negative and then positive, but it has now a decimal point. Okay, and then for the irrational numbers, we have this example. So square root of 2, square root of 3, the pi itself, and then square root of 11, and many more. Okay, so if you guys need to learn more about irrational numbers, so you can search on the internet. Okay, and next we have here the set builder notation. So let S a set and let P of X be a property that elements of S may or may not satisfy. So we may define a new set to be the set of all elements X in S such that P of X is true. So we denote this set as follows. Okay, so this is the denotation, okay, or how we read like a language or set, okay, in a this one in set builder notation or in a shorter way, okay, or via code name. Okay, so we have of course the curly bracket itself, and then we have this X, meaning it is the set of all X, okay, element S such that P of X. Okay, well, this one is quite confusing at first, but we read this one as the set of all elements X in S such that P of X is true. Okay, so you guys don't actually need to memorize this one. It's just that, if ever that you would like to, read a certain set builder notation, yeah, this is how you read this one: the set of all elements X in S such that P of X is true. So for you to be able to appreciate this one, okay, because if it's your first time, so it's quite confusing, but let's have an example, okay, for you to appreciate what is the usage of those notation. Okay, so given that R denotes the set of all real numbers, okay, and then Z is a set of integers, and then Z plus is the set of all positive integers, and Z minus is a set of all negative integers, describe each of the following sets. So X is an element of R such that X is ranging from -1 up to +4. Okay, wherein element X is just a whole number, because so I actually added this one because if we're going to talk about real numbers, you can start with -1.9, -1.8, -1.7 until 1.1, so we don't want that a super long result. So what I did is I just limited the numbers into a whole number only, so that we can have a result of 1 to 4. Okay, so we can also reduce 1x is less than -2, or x is greater than a -2, sorry, and then x is less than 5. Okay, so wherein if you are going to list all of the elements, okay, it would be -1, 0, 1, 2, 3, and 4. Okay, so yeah, that is already the answer for the letter A. Okay, and then for the letter B, who would like to answer letter B? So X is an element of Z. So what is Z? So it is a set of integers, so such that X is greater than -2 and X is less than 3. So I would like you guys to list all of the elements. Okay, so we have here. Okay, so the answer of Mr. Sian is incorrect. So the correct answer is the answer of Mr. Jeyo and Mr. Chris and Tristan Lanuza. Okay, -1, 0, and then 1 and 2. Okay, so remember that in integer, so we have this negative number, including the 0 and then the positive numbers. Okay, so how about the letter C? So I'll not reading it anymore, so I'll leave the analysis part to you guys. So what is the answer in letter C? We have Z plus only. Okay, so until now, this one is still quite controversial. Is 0 a positive integer? Guys, is 0 a positive integer? Yes, it is an integer, but is it positive? Is it for sure? It's not negative, but is it positive? Okay, so let's agree with one conclusion. Okay, so let's finalize everything now. So 0 is not a positive integer, so neither nor a negative integer. Okay, so it's neutral. All right, so when we say z plus, okay, we're going to start with 1, positive 1 and above. Okay, so the correct answer for this one is 1, 2, 3, and 4. Okay, how about letter D? Okay, so it's just -1. How about letter E? Anyone? It's not 0. Yeah, so the correct term is actually null, okay, or empty set. Okay, so you can answer, okay, dito na lang sa brush. You can answer this symbol, okay, means it is an empty set or just a set with no elements. Okay, this one is correct, this one is also correct. If there are no elements exist in that set. Okay. All right, so time check. It's maybe now 50 seconds left, 50 or 40, I'm not sure. But yeah, so that's it for now. We'll just continue the rest on the part 2. So goodbye for now and see you guys later. Okay. On, let's talk about subsets. So subset is a basic relation between sets. Okay. So ito yung pinaka-definite or pinaka-technical definition ng subset natin. So let's say we have A and B as a set. Then A is called a subset of B, written as this one, A subset of B, if and only if every element of A is also an element of B. Meaning, all of the elements of A can be found on set B. Okay? So, again, ito yung symbol ng subset. So, the phrase says A is contained in B and B contains in A are alternative ways of saying that A is a subset of B. Okay? So, vice versa. So, ang mahalaga lang naman is yung nasa left side, lahat ng elements nung nasa left side, which is A, is also in letter B. So we could say that A is a subset of B. Pero kapag merong isa na hindi mahanap sa set B, so we could not say that this one is a subset of set B. Okay. So for you to understand this one a little bit more, we have here an example. We have set A, B, C, D, E, and then A contains habit, AIT, BIP, IP, and then T. So in here, you could say that B is a subset of A. Tama?
Yes, sir.
Okay. So again, napakasimple lang naman ng rule natin. If the elements of this one can be found on this set, then we could say that this set or this set B is a subset of this set A. So we have here A that can be found in set A, letter I that can be found on set A also, and then letter T that can be found on set A. So we could say that B is a subset. Copy ko lang. Pwede kaya? Okay. So B is a subset of A. How about the others? Pwede rin ba nating sabihin C is a subset of A?
Yes, sir. Pwede, sir.
B is a subset of A. Pwede?
Yes, sir. Pwede rin,
Yes,
sir.
sir.
Okay. How about B is a subset of C?
Yes, sir.
Pwede, sir.
Alright. So how about D is a subset of E?
No, sir.
No, sir.
So hindi na kasi ang meron lang dito is letter T lang pero hindi na natin mahanapan yung element I sa set E. So this one is false. Okay, so ganoon lang naman kasimple kapag nahanapan niyo yung elements ng nasa left side papunta sa right side, then that is true. Pero kapag merong isang wala or hindi mo mahanap dun sa right side, then that is already false. Okay. So let's answer this one. Is C a subset of B?
No.
C a subset of B? So
No.
false. Tapat natin. Ayan. So false siya kasi meron nga tayong I sa T pero hindi naman natin mahanapan yung element B sa set B. Okay? How about C is a subset of C itself? Is this true or false?
True,
C
sir.
is a subset of C. This one is true. So any subset of itself is a subset of itself. So kasi lahat naman ng element nung nasa left side is meron din sa right side kasi nga sarili niya rin naman yun. Or mirror niya na lang naman na yun. Okay. So this one, C is a subset of C is true. Kasi nga ito lahat yung BIP natin is nasa set C rin naman. How about B is a subset of C?
False.
B is
False.
right. So this one is false. Oops. Baka pala. Okay. Kasi meron nga tayong I sa kati again, pero hindi naman natin mahanapan yung element A sa set C. Okay. How about the last one? C is a subset of B. Oops. Naulit yata. Naulit nga. So don't mind this one.
False, sir.
This one is also false. Okay, so ganun lang naman kasimple yung idea or concept ng subset. Okay, so moving on is a proper subset. Okay, so ito yung symbol ng proper subset natin. So kapag subset, merong underline sa baba. Okay, itong ganito. But for proper subset, wala siyang underline sa baba. So again, we have, let's say, A and B as a set. And then we could see that A is a proper subset of B if and only if every element of B is in B, but there is at least one element of B that is not in A. Okay? So, ano ibig sabihin nun? So, dapat itong element na nasa left side is meron pa rin sa right side. Kaso nga lang, dapat merong isang element, okay, dito sa set na nasa right side na wala sa nasa left side. So, ibig sabihin, hindi pwedeng maging kaparehas yung nasa right side sa left side. Okay? So, there should be at least 1, 2, or 3, or 4, and above as long as merong isa. Okay? So, para mas maintindihan nyo to, we have here an example. So, example of subsets and proper subsets. So, we have here set A, wherein it has an element of positive integers. And then set B, wherein it has a set of natural numbers, okay, or element n, ranging from 0 to 100. And then C is 100, 200, 300, 400, and 500. So evaluate the truth and falsify or falsity if each of the following statements are true or false. Okay, so letter A, B is a subset of A. Is this true or false?
True, sir.
So B or all of the elements of set B can be found on set A. Kasi lahat naman to is ranging from 0, kaya na sabi nyo kanina, so kasama na natin yung 0 sa positive integers. So 0 to infinity. Wherein in here, set B is ranging from 0 to 100. So A is, okay, how about letter B? C is a proper subset of A.
True, sir.
Okay, so this one is also true. Kasi nga, mahahanap po rin naman yung 100
True.
sa A, 200 sa A, and so on and so forth. Okay, how about letter C? C and B have at least one element in common.
False, sir.
So this one is, how about at least? Okay. So ang term naman dito is at least. So pwedeng kahit isa lang and then
True.
above. So letter C is true. Okay. How about letter D? C is a subset of B. True or false? Anyone?
False.
So this one is false. Kasi nga, wala naman tayong 200, wala naman tayong 300, 400, and then 500. So we only have 100, okay? So this one is not a subset of set B. How about letter E? C is a
True.
subset of itself. So any subset of itself is a proper subset. Okay? Or a subset pala. Hindi lang proper subset. So balikan natin itong first example natin. So kagaya ng sabi natin kanina, B is a subset of A. Okay? But how about this one? B is a proper subset of A. Is this true or false?
False.
True.
True siya.
True, sir.
Okay. So actually, same lang sila ng subset natin. It's just that, itong next example. C is a proper subset of C. Is true or false?
False, sir.
False, sir.
So false na to kasi lahat ng element ng C can also be found on set C. Okay? So in other words, hindi pwedeng maging proper subset ang isang or ang sarili niya. Okay? Na kompleto din. So pwedeng ito, D is a proper subset of C, which is already true. Kasi meron tayong I dito sa letter C, meron din tayong T dito sa letter C, pero merong isang wala. Okay? So in other words, dapat mas maraming element yung nasa right side kaysa sa left side. Unlike if it's a subset, so as long as meron yung element dito sa right side, proper subset na siya. Pero sa proper subset na siya, okay? Sorry, gulo-gulo. So subset na siya. Pero sa proper subset, dapat merong isang wala. Okay, at least one. So E is also a proper subset of C. So meron tayong P dito, hindi naman natin mahanapan yung B at saka I, so okay lang yan. As long as meron itong element na to dito sa right side natin or sa letter C. Okay? So yun lang naman yung pinagkaiba ng subset sa proper subset. So after that, expect that you're going to have a quiz, of course. So iwanan ko na sa inyo. So just answer this one on Canvas. So true or false lang naman siya. Okay? So next one is distinction between element, and then kapag may underline, that one is a subset. Pag walang underline, that's a proper subset. Okay? Okay, so let's answer those questions. So which of the following are true statements? So anong sagot natin sa letter A? Is this true or false? Two is an element of set 1, 2, 3.
True, sir.
This one is true since this number is an element of set. Wala siyang set name, pero set 1, 2, 3. Okay. About letter B? Set 2 is an element of 1, 2, 3. Or set 1, 2, 3.
True, sir.
False. Okay. Kasi nga, ang hinahanap natin is also a set. Saan yung ating graph? Okay. So, kung isusulat natin to, meron tayong okay. So, ito yung hinahanap nating element itself. Okay. Wherein, dito sa kabila, ang laman neto is 1, 2, and then 3. So you should find the exact image, okay, on this one. Wherein sa kabila, it's just a set wherein it contains 1, 2, and 3. So kung sa kabila sana is ganito din, okay, or naka-enclose yung 2 natin sa set, then we could see that letter B is true. Okay? I hope this one is clear. How about letter C? Is this true or false? So
True.
2 is a proper, 2 is a subset. Ano naman tayo, proper na. 2 is a subset of 1, 2, 3. So 2. Oops. Okay, how about letter D?
False.
So set 2, true na siya. Okay? So dapat kapag proper subset or subset, dapat set silang pareho. Okay? Kasi nga, yung pinagko-compare natin, kung maalala nyo to, A is a set and then B is also a set. Wherein, in letter D, yung left side natin is already a set. So set 2 and then the other one is set 1, 2, 3. So letter D is true. Okay? So this one is a proper na naman. This one is a subset of this set. Okay? So, take note yung mga ganong kwan natin, okay? How about letter E?
True na rin yan, sir.
This one is false.
True.
Kasi nga naka-enclose yung isa sa set pa, okay? So ito set, tapos meron pa ulit set. And then,
Ay, ganun.
but this one is just a set wherein we have an element of 2. So dapat dito, element 2 lang siya, hindi na siya set with an element of 2. Okay? How about the last one, letter F? So,
True, sir.
set 2 is an element of the set. So this one is true. So pag element, dapat exact siya dito sa kabila. Wherein, this is a set wherein meron tayong set ulit, which is also number 2. Okay? So moving on, after that, of course, you're going to have a quiz. So still true or false. So A, B, C, D, and then E. Okay? Just identify whether this one or those numbers are true or false. Okay? Moving on, next one is ordered pairs. So I hope alam nyo na to since I think ginawa nyo naman na to dati yung x-axis and then y-axis or yung ordered pair natin sa dalawang yon. So what is the meaning of ordered pair? So let's say given elements A and B, we have an element A and B. The symbol AB denotes the ordered pair consisting of A and B together with the specification that A is the first element and then or A is the first pair or first element of the pair, and then B is the second element of the pair. Okay, so we have here two ordered pairs, the A and B, and then C and D. Okay, so we could see that A and B is equal to C and D if and only if A is equal to C and then B is equal to D. Meaning the value of A is equal to C and then the value of B is equal to D. Okay? Kasi nga, first to first and then second to second. Okay? So you could write this one symbolically. AB is equal to CD means that A is equal to C and then B is equal to D. Okay? So take note, in ordered pair, mahalaga na yung first na positioning and then second position or first term sa second term kasi yung first term is just a first term and then the second term is just a second term. Okay? So we could see that this first term is equal to this other first term if they have the same values. So the same with the second term of this one and then the second term of the other one. Okay? So let's have an example. Is 1, 2 equal to 2, 1?
False, sir.
So letter A is false since again, mahalaga na yung term dito or yung position natin. So first term is the same or should be equal with first term. Wherein in here, 1 is not equal to 2. Okay, and then 2 is not equal to 1. Okay, so hindi na siya kaparehas ng set na wherein pwede mong pagbalik-baliktarin or kahit anong sequence. How about letter B?
True, sir.
True.
True.
Letter B is true. So in here, you can simplify this one a little bit more. So 5 out of 10 or 5, 10 is 1/2. And then in here, pwede mo rin i-simplify wherein square root of 9 is 3. So letter B is true. How about letter C? What is the first element of this ordered pair?
1.
So 1. Okay, so kahit anong isagot nyo, parehas lang din. Okay, so moving on, we have here a Cartesian product. Okay, so given sets A and B, the Cartesian product of A and B, denoted A times B, and read as A cross B, is the set of all ordered pairs AB, where A is in A and then B is in B. So kapag sinabi natin A times B, so kukunin lang natin lahat ng elements or set or ordered pairs ng set A. The same with letter B, kukunin lang din natin lahat ng ordered pairs ng set B. And then all we have to do is multiply. So kapag may multiply kayo, is same lang siya ng normal mathematics. So papakita ko sa inyo kung paano mamaya. Okay? So in here, this A and B is symbolically A times B or A cross B is equal to AB. Okay, first element is A and then B is the second element, such that A is an element of set A and then B is an element of set B. And then AB is equal to AB. Parang weird to Okay. Seems na may correction dito. Anyway, disregard nyo muna to. Okay, I think hindi to kasama dito. Or may nabura lang ako. Okay. Anyway, pwedeng kahit wala naman na yan. Papaliwanag ko sa inyo yung full definition mamaya or yung full meaning. Okay? So, para mas maintindihan nyo, dito ko na lang papakita sa example. So, it says here, list all the set of ordered pairs on the following. So, we have here set A that contains an element of 1, 2, 3. And then set B contains an element of UB. So, we have here the first question, find A times B. So what are the ordered pairs of letter A? So ako nang sasagot para sa inyo. A times B is equal to set. So our first ordered pair is 1U. Our second ordered pair is 1V. So basically, para ka lang nagmo-multiply. Dinidistribute mo lang. Okay? So yung tawag natin dito is yung parang FOIL method. So yung first in, tapos outer at saka yung pinaka last layer. Parang ganun. And then the next one is 2U. 2U and then 2V. And then the last one is 3U. And then 3V. Okay? So, ganun lang sa letter A. So, basically, minultiply nyo lang or dinistribute nyo lang yung mga elements natin. Okay? How about letter B? Anyone who wants to volunteer? Times A. So what are the ordered pairs of B times A?
U1, sir.
Okay, so U1. Oops. What's next?
Mm, U2, sir. U2.
Okay, next one.
U, U3, sir.
Next.
B1.
B1. Next.
B2.
Next.
B3, sir.
Okay, so ganun lang kasimple. So para lang kayo didistribute. Okay? How about letter C?
UU, sir.
P times P equals, okay, so UU, what's next?
BB, sir. BB, sir.
BB. Ano pa?
UV.
UV. Ano pa?
View.
Last
VU.
one is VU. Okay? So, multiply nyo lang yung sarili niya. UU, UV, VU, saka VV. Okay, ganun yung tamang arrangement kung sakali. Okay, how about the last one? How many elements are in A times B, B times A, and then B times B? So, para hindi kayo mahirapan dito, okay, ang pinakamadaling way is find the count of elements of A and then the elements of B. So, meron tayong 3 elements saka 2 elements. So, for this one, ito pinakauna, 3 times 2 is 6. Plus, B times A, so binaliktad lang. So, 2 times 3 is still 6. The last one is B times B. So, ilan yung elements dito?
4.
Plus 4. So, ilan yung nakuha natin? 6 plus 6 plus 4 is 16. Okay, so we have a total of 16 elements from A times B, B times A, and then B times B. Okay, so ganun lang naman siya kasimple. Okay then, so here are the answers. Okay, wherein we have already answered that one. So most of you were able to get the correct answer. So I'll just give you guys maybe 10 seconds to 15 seconds to recheck everything. Okay, so again, in order for you to know the total of elements or total combinations, just count the elements on that set versus on the second set. So 3 times 2 is 6. And then B times B is 2 times 2 is equal to 4. Okay. So let's now proceed to the different types of set. So empty set or null set. So they are just the same. So a set which does not contain any element is called empty set or the null set or the void set. So there's actually 3 names for that. We have empty set, null set, and then void set. So those 3 are just the same. Denoted by this, I think this is P, PHI. So yeah, so I'm correct. So it's P. So in roster form, P is denoted by this empty set. Okay, curly bracket, which doesn't have an element at all. Okay, and an empty set is a finite set also, since we can count the count of elements inside of it, which is actually none. Okay, so it's under finite set. And then since the number of elements in an empty set is finite, for example, it's 0. So this is just the number of cardinalities, meaning it doesn't have any count of elements. So for example, the set of whole numbers less than 0. So of course, clearly there is no whole number less than 0, because in whole numbers, we only have 0 and above. Okay, we don't have negative numbers. So therefore, it is an empty set. So I think this one is quite easy to understand. Okay, so anyway, let's have another example. So we have this set n, which x is an element of n, wherein x is greater than 3, and then x is less than 4. So n here is actually natural numbers. Okay. So in natural numbers, we start with 1 and above. So 1, 2, 3, 4. And if you guys are going to take a look on this one, there is no number in between of 3 and 4, since it's only under natural, natural numbers. Okay. So here A is an empty set because there is no natural number between 2 and 3. Okay. And then for the letter B, or let B is equal to x is a composite number less than 4. Okay, so if you don't know what is a composite number, so I have the definition of composite number here. So composite number is a positive integer that can be formed by multiplying two smaller positive integers. Equivalently, it is a positive integer that has at least one divisor other than 1 in itself. So as a result, this set B, or here B is an empty set because there is no composite number less than 4. Okay. So 2 and 3, so we cannot form a number since we have to multiply a whole number. So we cannot multiply 1.5 times 2 since 1.5 is not an integer anymore. Okay, so that is a composite number. Okay, so just take note that this one is not equal to this one. So this one is empty set itself. Okay, but this one is a set that has one element, which is 0. Okay, and then the cardinality, or the cardinal number of an empty set, is of course 0. Okay, so 0 count of elements, but this one has a cardinality of 1. So when we say cardinality, it is a count of elements inside of that set. Okay, so we'll talk about more cardinal numbers later on. But yeah, that is it for the empty set or null set. So are we clear so far? Question or clarification before we proceed to the next one? Okay, so I would assume that there is none since no one is speaking. So let's now proceed to the singleton set. So this one is also super obvious. Singleton has only one element. Okay, that's why it's called single or singleton. So for example, x is neither prime nor composite. So again, if you don't know what is the meaning of prime number or composite, has been already mentioned here. But a prime number or a prime is a natural number greater than 1 that is not a product of two smaller natural numbers. So a natural number greater than 1 is not a prime is called a composite number. So for example, 5 is prime because the only ways of writing it as a product is 1 times 5 or 5 times 1 involves 5 itself. So it has to be, the number itself has to be there for us to be able to call that one as a prime number. But if the number itself doesn't exist, we call that one a composite number. Like 2 times 2 is equal to 4. Okay. So in here, where is it? What it is a singleton set containing one element. Okay. So this one is neither prime nor composite. Okay. So let's have another example. Is let's say B, x is a whole number wherein x is less than 1. And let's go back to the whole numbers. So we only have 0, 1, 2, 3, and 4. Okay, so the only element that is less than 1 is 0. So that is why this one is called singleton set. And then for the third one, we have here x is an element of n and x squared is equal to 4. So in here, we now have two conditions. Okay, so the first condition is x is a natural number. So what are those natural numbers? So we have 1 and above. And then we have another condition wherein x squared is equal to 4. So we must meet two conditions for us to be able to say that it is an element of that certain set or that set A. So in here, there is only one element that can suffice those two conditions. So that is actually 2. So 2 squared is equal to 4. So there are no other numbers anymore that can suffice this one. unless this one is not a natural number. If this is an integer, so we can have -2, but that is not a singleton set anymore since we now have two element on that set. Okay. And then for the last one, so let B, wherein x is an even prime number. So here B is a singleton set because there is only one prime number which is even, okay, which is the 2 itself. Okay, so there are no other other even prime numbers that exist except the 2 itself. So are we clear so far when it comes to singleton set? Hello? Are you guys still around?
Yes,
Or nagutom na?
sir.
Okay? Oh, ang paulan na. Last ng thunderstorm. Anyway, let's proceed now to the next one, which is called the finite set. So this one is super obvious. It's called finite because we can count the number of elements inside of that set. Okay, so it has a limitation. Make it short. Okay, so in here we have 2, 3, 5, 7, 17, and up to 97. So it has a limitation. Okay, so the counterpart of that one is of course infinite set. Oh, infinite. The name itself already is saying the correct answer. Wherein we cannot count or we cannot list all of the elements inside of that set since it's infinite. Okay. So all infinite sets cannot be expressed in roster form. Okay. And then let's now talk about cardinal number of sets. So again, when we say cardinal number of sets, so it is a number of distinct elements in a given set. Set A is called the cardinal number of A. So it is denoted by n, closing up in parentheses, A. So meaning you are like saying the count of elements of A is equal to, so depending on how many elements or how many distinct elements we have in that set. So take note, it's distinct elements. So repeated elements must be removed first before you can count the cardinality of that set. Okay, so for example, we have this one, x is an element of n, and then x is less than 5. So again, in natural numbers, we only have a 1 and above, so 1, 2, 3, 4. So in here, we have 1, 2, 3, and then 4. Okay, so if you guys are going to count the distinct elements inside of the set A, we only have 4. So are we clear so far? So it's like, cardinal number is equal to the count of elements of that set. So did you guys get the idea so far? Okay, so the same with letter B. So B is equal to set of letters in the word algebra. And if you guys are going to take a look at this one, so if you are going to count this one, so we have 2, 4, 6, 7. Yes, we have 7, but then again, we have a repeated elements, which is A. So we can just remove the other one. So as a result, we now only have A, L, G, E, B, and then R. So we now have a total of 6 elements instead of 7. Okay. So I hope we're clear with the cardinal number of the set. Okay, so let's now proceed to the next one, which is the equivalent sets. So this one is two sets A and B are said to be equivalent if their cardinal number is the same. Okay, so most of my students before are confused with this equivalent and then equal. So when we say equivalent, so the one that we are looking for is the cardinality or the cardinal number of that set. So they must be equal in terms of counts of elements. Okay, so that doesn't matter if they have different distinct elements inside of them. Okay, as long as they have the same count of elements, they are already an equivalent set. Okay, so for example, this one, we have a set A which contains an element of 1, 2, 3. So the cardinality of this one is 3. And we have PQR for the letter B. So we have a cardinality of 3 also. So we could say that A is equivalent to set B. Okay. So are we still good? Were you guys able to follow so far? Okay. And then the one that we are talking that, they must have the same elements. So this is not the one that we're talking about. So the equal set. So we call that one equal. Okay, wherein let's say A is equal to PQRS and B is PSRQ. So therefore we can say that A is equal to set B, or set A is equal to set B. Okay, so again, in set arrangement doesn't matter. So those two are equal. And at the same time, you could say that they are equivalent also, since they have the same count of elements, okay, or they have the same cardinality. Okay, so I hope we're clear with the equal sets. So let's now proceed to the next one, which is the universal sets. So universal set is the set of all elements under consideration. So we could just say that universal is like the universe itself. Okay, so we could say that, in universe, it is a set wherein it contains the planet, Earth, Mars, Jupiter, Pluto, and so on and so forth. Okay, so it has a boundary, of course. After that one, the wide, after the universe, of course, is the galaxy. Okay, but let's just stick with the universe or universal. Okay, so this one is denoted by capital U. So this one is all other sets are subsets of the universal set. So again, it has a limitation. That doesn't mean that it's unlimited, or it's not bounded. So in here, it's bounded by this element. So given U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so those are the elements that it can contain. Okay, and then we have set A, which has an element of 1, 2, 5, 6, and then set B, which contains an element of 3 and 9. So below is a Venn diagram to represent these sets. So this is the U itself. Okay, and then we have subset A, which contains an element of 1, 2, 5, 6, and then set B, which contains an element 3 and 9. And then the other that doesn't exist is just, inside of that U also. Okay, it's just that it is not inside of a certain set. Okay, we have 4, 8, and then 7. So think of a universal set as a big picture. It includes everything under consideration, which is depending on, the elements that's being mentioned, or everything that is relevant to the problem you have. An example above, or on the left side, we have A is a subset of U, and then B is a subset of U also. So note that subsets A and B do not overlap, so these sets are disjoint. Okay, so are we clear with the universal sets? So any questions so far? So I think we can finish. Yeah, I think we can finish it today. So let's try to finish this entire module to today. Anyway, so let's now proceed to, oops. Okay, so we have already answered this one. I don't know why is it here. Okay, so we will skip this subset and then this proper subset topic, since we have already discussed this one a while ago. Okay, but it's just in case that you need more example or clarification. So these are the answers. Okay, so the same with this one. Okay, for the proper subset. Okay. Okay, so let's talk about now superset. So when we say superset, it is a set containing all of the elements of another set. So it's like the mother set, the one that I keep on saying a while ago. Okay, so if you are going to draw this one, so A is the superset of B. Okay, meaning this is now the like the mother set, or the one that contains all of the element of set B. Okay, so we have this example: A is equal to habit, B is AIP, and so on and so forth. So these are the answers. A is the superset of B because all of the elements of B can be found on superset B. A is the superset of C because all of the elements of C can be found on superset E. A is a superset of B. Oops, naulit. Okay, so let's just ignore this one. And then A is a superset of B because all of the elements of B can be found on superset E. And then A is a superset of E is also true because all of the elements of E can be found on superset E. Okay, or you can also add D is the superset of E. Okay, since all of the elements of E can be found on superset D. Okay, so
Sir.
yes.
Ano yung difference nilang dalawa ng universal set?
Why do you compare that one to superset? Universal set is like a rectangle or just a big picture which contains a certain elements. Okay, and superset is a set that contains all of the elements of its subset or proper subset. So I don't think we can compare those two. So there is no comparison since both of them are two different, representation or topic. Well, we can compare subset and proper subset, but the same with superset, we can compare those three. But universal set is just a representation of a bigger picture of something. Okay. So where is that part that you are, getting confused? So could you please elaborate more?
Sir?
So parang what do you mean? Like what is your difference?
Hindi kasi sir, parang 'di ba, yung universal set.
Mhm.
Lahat ng yung dito sa example dito, A and B, lahat ng elements na is nasa universal set.
Mhm.
Then dito naman sa superset, yung element ng A, lahat ng element ng B, C, D, at E ay nasa A. Parang ganun.
That's right. You can also say that this is the universal set already, but still, we can still call this one as superset. We can also call this one a superset. Okay, since C is the superset of D, since we can still find the elements of D on C. Okay, so unlike in universal set, there's only one. Okay, which is this elements, but for superset, so four of them can become a superset actually. Okay, but yeah, you're actually also correct that we could say that A is like a universal set. 7, 8, 4 are not subsets. No, they are not subsets. They are just element inside of that universal set. Okay, so again, when we say subset, so it must be inside of a set also. Okay, wherein 7 is just an element, 8 is just an element, the same with 4. Okay. Was I able to answer your question? That makes it
Yes.
different to superset?
Yes po.
Yes, pwede. So in universal set, so yeah, that one is correct. 7, 8, and 4 is not a subset. Unlike in superset, so the letter B, C, B, D, and then E right here are the subsets already. Okay. So you can actually, just flip this one, and this one now is like a subset. Any other concerns before we proceed to the next one? Okay, So any other question, Mr. Sian? Was I able to answer your question?
Yes po.
Okay. What about you, Mr. Derek Prince Umanhan? Do you have any other concerns? So it seems that, okay, so it's here. Okay, so let's now proceed to the relation. Okay, so to make it simple, relation composes of two elements, okay, wherein we must have this first element and then this second element for us to call that one as a relation. So the same with, how we call that we are related to to our parents, and we are related to our friends, or how we are related to our maybe colleagues. Okay, so those are called relations. So in here, relation R from A to B is a subset of A times B. Given an ordered pair x, y in A times B, x is related to y by R, written x related to y, if and only if x and y is in relation. So we can only say that x is related to y if it meets the condition. Okay, so later on, I will have an example with this one. So the set A is called the domain of R, and set B is called its codomain. So the first element is the domain, and then the second element is the codomain. Okay, so the notation for a relation R may be written symbolically as follows. So x or y, or x is in relation to y, means that xy is an element of R, or an element of relation. Okay, so the notation x is not related to y means that x is not related to y by R, or in symbolic form, x is not related to y means that xy is not an element of R. So they are in relation if they were able to meet the condition, but they are not in relation, okay, or they are not in or they are not an element of R if they wasn't able to meet the condition. Okay, so for you to be able to say that yes, they are in relation, this A and B is in relation with each other, so you must be able to meet the condition first. So that is the one that we are going to look for us to be able to say that they are in relation with each other. Anyway, let's have an example. So a relation as a subset. So we have set A as 1 and 2, and then set B as 1, 2, and 3, and define a relation R from A to B as follows. So given any x, y is an element of A times B. So in here, you must get all of the ordered pairs first, okay, because we can only say that they are in relation if they were able to meet this condition. So with that, you have to list all of the ordered pair first, and then substitute the values of x and y in this condition. So x and y is an element of R, means that x minus y divided by 2 is an integer. So if it's an integer, then they are in relation. But if it's not an integer, then they are not in relation. So with that, let me just check if we have the result. Yeah, okay. So to make it quick, okay, so all you need to do is list all of the ordered pair first. So we have 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Okay. And here are now the list of ordered pairs. Then after that, you have to substitute the values of those ordered pairs on our condition, wherein x minus y divided by 2 is an integer. So here are all of the results. So we have 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and then just substitute the values right here. Okay, so 1 minus 1 divided by 2 is equal to 0 divided by 2, which is equal to 0, which is an integer actually. Okay, and then 1, 2 is actually equal to negative 1 divided by 2, or negative 1 half, wherein negative 0.5 or negative 1 half is not an integer. And so on and so forth. So all you need to do is substitute those list of ordered pairs, and then just get all of the relations that is, we're able to meet the condition. So we have 3 that was able to meet the condition. So we have ordered pair 1, 1, ordered pair 1, 3, and then ordered pair 2, 2. And then just ignore the rest. Okay. So where is okay? So this is already the answer for the letter A. So what is the question in letter A? So state explicitly which ordered pairs are in A times B, which are in R, or which are in relation. Okay, so we only have 3 relations. So 1, 1, 1, 3, and then 2, 2. So were you guys able to follow the letter A? Is it clear so far? So 9 slides left. Thanks. And 8 minutes remaining. Okay, so this is the answer for letter A, and then this is the answer for letter B. So is 1 related to 3? So just base it right here. So 1, 3 is yes. So that's why we have an answer of true. And then 2, 3. So 2, 3 is not an integer. So that's why we have an answer of false. And then 2, 2, okay, is yes. So that is why we have an answer of true right here. Okay, so are we clear with letter B? And then for the last one, so this one is super simple. What are the domain and codomain of relation? So all you need to do is get the ordered pair which is in relation. So we have 1, 1, 1, 3, and then 2, 2. So we have for the domain, okay, so we have 1 to right here because we have 1, and then we have 2. Okay, so we have 2 repeated 1, so just remove that 1 since we only need 1. So that is why we have 1 and then 1, 2. So that is already our domain, or the first element for the relation or pair. And then for the codomain, so that is the second element. So we have 1, we have 3, and then we have 2. So as a result, we have 1, 2, and then 3. Okay. So for this one, you guys have to check the ordered pair which was able to form a relation. Okay. So are we clear with the letter C, the domains and codomains?
Yes, sir.
Okay, very good. So answer as quick as possible since we are now running of time. So let's have another example. So the circle relation. So define a relation C from R to R as follows. For any x, y is an element of R times R. So this R right here is a real number. So any number that you can think of. Okay. So x, y is an element of C means that x squared plus y squared is equal to 1. So all you need to do is get all of the possible combinations. But it would be infinite, of course, since especially we're talking about real numbers, so it's like everything already. So we have a given ordered pair in here, okay, wherein is 1, 0 is an element of C. So is this ordered pair in relation with each other? So before it was represented by R, but in here it's now represented by C, meaning it's a circle relation. So again, for us to be able to say that they are in relation, if you were able to meet this condition, x squared plus y squared is equal to 1. So this is the x and then this is the y. So 1 squared is 1, and then 0 squared is 0. So 1 is equal to 1. So A is yes. How about letter B? B is no, that's correct. Very good, Mr. Jeo. Letter C? So for this time, I would like you guys to use your calculator. Unless you're a math genius and you can compute this square root of 3 divided by 2. Okay, so the correct answer is yes. Okay, so to the others, please verify this one. And then for letter D, so this one is super obvious. Letter D, is it yes or no? So this one could be represented by, this one. Is this ordered pair an element of circle relation? or we could just say is -2 in in relationship with element O. I mean 0, not O. So letter D is no. Okay. How about letter E? E. What is the answer in E? So yes, correct answer is yes. Okay. What about letter F? Yes. Okay, the correct answer in letter F is no. Okay, 1 squared plus 1 squared is already equal to 2, wherein 2 is not equal to 1. So 1 is not in relation with 1. Okay, and then what are the domain and codomain of C? Okay, so let me answer letter G. So in here, the domain and codomain are this. Okay, so anything is actually possible, and then we cannot list everything. So in other words, we can just say that the domain and codomain of circle relation is R, okay, or real numbers. Okay, so we've just used those numbers to answer this uh, relation right here with this condition. But to make it exact, all of the domains is R, and then all of the codomains is R also, or RR. Okay, since marami sila. Okay, so here are the answers. So we now only have 1 minute and 45 seconds left, and we still have 7 slides remaining. Anyway, so I think we cannot finish this one today, unless you guys are willing to, have another meeting. Is it okay? Will it be okay, guys? We're going to have a part 4, maybe just maybe 5 to 10 minutes. Just to finish everything. So so that you guys can answer everything now. Okay, those 8 quizzes. Okay, since we still have two topics left: the arrow diagrams and then the function. Okay, anyway, so let's have another votation. So 1 minute left. So are you guys willing to have a part 4?
Yes po.
Okay, what about the others?
Okay
10
lang
minutes lang
po.
naman.
Yes,
Okay
sir.
lang.
Okay, so I will end our meeting now, and then let's just meet on part 4. Okay, so 7 slides left. Okay, so goodbye, and let's just meet again on part 4. Okay.
Pag-mute ako lang.
All right, so once we've reached maybe a total of 20 participants, or maybe 25, we'll start right away. Okay. Okay, 19, 20. But that's still 19 since I'm part of the participants. Okay, let's wait one more participant. But anyway, this is recorded. So to those who won't be able to join as soon as possible, they can just watch this one. All right, so maybe we'll just wait 1 minute. At exactly 5:35, we'll start right away. Okay. So how are your other subjects right now? Are you guys doing good? Is it easy? Is it fine? Mr. Fardo, since ikaw yung nakikita ko ngayon. Okay.
They're fine. Some classes have more stuff to do than others.
So you could say that my subject to you right now is a lot easier than the other subject.
Not really. I'd say about average. I like the challenge.
Sure.
I see. Well, to be honest, my subject is actually super, super basic. I'm pretty sure that you guys have watched
Super basic ka dyan. Here.
Yes, Mr.
Paano pa
Patricio.
silang dalawa?
Okay, well, anyway, so we now have a total of 22 participants, and it's now 5:35. So let's continue now our discussion. So for the second to the last topic is we have the arrow diagrams of a relation. So suppose R is a relation from a set A to a set B. The arrow diagram for R is obtained as follows. So represent the elements of A as points in one region and the elements of B as points in another region. For each X in A and Y in B, draw an arrow from X to Y if and only if X is related to Y by R. Well, to make it simple, you can just base it on the symbolic form. Draw an arrow from X to Y. So the first element is X and the second element is Y. And you can only do that if and only if is in relation with each other. Okay, so don't draw an arrow if they are not in relation with each other. Okay, so here's an example. Let A is equal to 1, 2, 3, and then B is equal to 1, 3, 5. Okay, and define the relations S and T from A to B as follows. So A is 1, 2, 3, and then B is 1, 3, 5. And then you guys have to stick with the where is the formation or the correct representation here. So if it says A to B, then A first before the B. So vice versa. If it says here B to A, then it must be B first before the A. Okay, that doesn't mean that A is the first here, and then that is now the one that you need to put in here. Okay, so that depends on the format. Okay, that will be given. So A to B. So we have A to B and then A to B. So this is the set S, and then this is the set T. So for the set S, here is the condition: X is less than Y. So we could see that they are in the relation if X is less than Y. So that is why we have 1 going to 3, since X is less than Y. We have 1 and then 5 because X is less than Y. We have 2, 3, 2, 5, and then 3, 5. Okay, so it's like transferring, or instead of having a coordinates like 1, 0, etc., etc. Okay, so we can do this representation, arrow diagram, which means 1 is in relation with 3, 1 is in relation with 5, 2 is in relation with 3, and so on and so forth. Okay, so all of those are in relation with each other. Okay, those are arrows. So are we clear? Are you guys able to follow the set S or relation S? Hello? Or still analyzing? So as long as it was able to meet the condition wherein we have X is less than Y, then you can draw that relation, or you can draw that specific element to this specific element. So the reason why we have one, we don't have 1 going to 1 on the other side, because 1 is not less than 1. Okay. So the same with 2 going to 1. 2 is not less than 1. But the others, so 1 is less than 3, 2 is less than 3, 1 is less than 5, 3 is less than 5. So are we clear now with set S or relation S?
Yes, sir.
Got it, sir.
Okay. In letter T, so there are no condition given. It's just that it says here that this is already in a relation. Okay. So we have 2, 1, and then 2, 5. So that is why we have 2, 1, and then 2, 5 in here. So as easy as that. Okay. So I think letter T is very straightforward, wherein you don't need to check any condition. Okay. So are we good now? What about the others? Mr. Domayan. Okay, this is again a random call. Mr. Domayan, are you around? Anyway, so again, maybe he's doing something. Okay, so let's move on now to the next one. We have here functions. So to make it simple, we need to form a relation first, and then in that relation, so some of them are functions and then some of them are not function. So we have another condition, or a rule or properties that we need to follow for us to be able to say that they are a function. So a function f from a set A to a set B is a relation with domain A and codomain B. So in other words, it's the same with ordered pair. It's the same with a relation. So it needs 2 elements, the first element and then second element, or the domain and then codomain. But then again, you have to follow these conditions. So for every element x in A, there is an element y in B such that xy is an element of f. So I think it's quite confusing. But yeah, that's the property, first property. So the second one, for all element x in A and y, z in B. Wherein if x and y is an element of function and x, z is an element of function, then y is equal to z. Okay, so in layman's term, or in stated less formal, we have this one. A relation f from A to B is a function if and only if A is the first element, okay, of that specific ordered pair, and then no 2 distinct ordered pairs in F have the same first element. Okay, so I think this one is still quite confusing, but yeah, those are the things that you can memorize now. So A is the first element, so that's the first rule. Second one is no 2 distinct ordered pairs. So for you guys to be able to appreciate this one, let's proceed now to the example. Okay, but before that, let's just talk about this notation, wherein we have if A and B are sets and f is a function from A to B, then given an element x in A, the unique element in B that is related to x by f is denoted by f of x. Okay, so the symbol of the function is f, and then the elements on that one is the x. So we call this one f of x. Okay, or this one can be read as f of x. Okay, so let's have these 3 examples. So let A is equal to 2, 4, 6, B is 1, 3, 5, and then which of the relation R, S, and P defined below are functions from A to B. So we have a letter A right here, which already has an answer. We have a relation 2, 5, 4, 1, and then 4, 3, and then 6, 5. Okay, so we are now given by a relation, so we don't need to check this one anymore. So it says here that this is already a relation. Okay, so the next thing that we need to check is whether this one is a function or no. Okay, so yes, this is a relation, but let's see. We have 2, 5, 4, 1, 4, 3, and then 6, 5. And if you guys are going to take a look on the rules, so yes, A is the first element, so that is true. Or meaning all of our first elements can be found on the set. Okay, But on the second one, okay, it says here no two distinct ordered pairs in F. Meaning, we must only have one ordered pair in this elements, okay, wherein we have two distinct elements, okay, which is before 1 and before 3. Okay, so this is not a function since we have two ordered pairs or two relation for the for 1 and for 3. So to make it simple, let's have this example. Let's just say that the first column, okay, is you, okay, and then the second column is your grade. Okay, so the 2 has a grade of 5, so let's just say that it's 90, and this student has 2 grade, okay, wherein he has a grade of 1 and 3, and it is not a function anymore, okay, since there is no way that you're going to have 2 grades, okay, so as a student you must only have 1 grade. Okay, so another example. So if you're a Catholic, okay, if you're not a Muslim, so let's just say that this is you, and then you must only have one partner. Okay, so in here it has one partner, 2, 5, 6 has a one partner, which is, but this is a sin already since this one has 2 partners. Anyway, so we're only talking on this left side. This guy has 2 partner, okay, which is, you know, in partner with 1 and then in partner with 3. So that is not also a function since that is you know, not a good idea. So the same with this so-called function. Okay, so all of the elements in this first element or the domain must have only one partner. Okay, and then for the codomain, so it can have, or yeah, it can have more than 2 partners actually. So that is okay. And sometimes, or it is also possible that it cannot have a partner or it doesn't have a partner. Okay, well, anyway, so the correct example for that one is letter C, wherein this one has the one partner only. This one has 2 partners, but it's okay. And this one doesn't have a partner, but it's still okay. Okay, this one is still a function for letter C. Okay, but for the letter B, so in here we have for all x and y, is an element of A times B. X and Y is an element of S, means that Y is equal to X plus 1. So in here, we have to check first the, you know, the one that is in the relation. So I've listed all of the possible ordered pairs first, and then I now put here the one that is in a relation. So we have 2, 3, and then 4, 5 only. So we have 2, 3, and then 4, 5. And then if you guys are going to take a look at this one, if it's a function or no. So 6 doesn't have a partner. Okay, so the same as like, you know, you're a student, but you don't have a grade, but the others has a grade already. So yeah, I cannot think of any other example that, you know, will let you appreciate why do we say that it's a function and it's not a function. But to make it simple, this domain must have a partner and one partner only. And then for the codomain, so some of them doesn't have a partner, and then some of them has a lot of partner. Okay, so those are the function or examples of a function and not a function. Okay, so here is the reference for my presentation, and that's actually it. So it's like we've consumed how many minutes? 17 minutes, I guess. So yeah, over time. Well, anyway, so I would like you guys to answer these 8 quizzes and then this 1 case study. Okay, and then we have one more topic, which is the problem solving. So we still have 3 meetings left. So hopefully we can finish this one next meeting, and then you guys can have the remaining 2 meetings as your free time. Okay, so a total of 8 hours. All right, so any question before we dismiss?
Sir.
Yes.
Dun sa ano, circle relation.
Second relation.
Circle, sir. Circle relation.
Circle relation.
Apo.
Mhm.
Diyan, medyo nagugulan ako, sir.
Which part or which number?
Yung A. Bale, yan mismo, sir. Yung topic niya. Circle relation.
Mhm.
Paano malalaman if if true or false?
If true or false. So,
Yes.
well, actually, you don't need to mind the name itself. It's just called circle relation because it's using this, formula. But yeah, this is the condition that you need to follow, wherein we have the x and then y. So all you need to do is substitute those domains and codomains in here. Okay, so we have 1 squared plus 0 squared. So if it's equal on the right side, then that is true already. Okay, or they are now in relation. So 1 squared is 1 plus 0 squared is 0. So 1 is equal to 1. So that is why it's true.
Okay po.
And then do the same on the other ordered pair or other relation. Okay, so any other concerns?
Sir, paano naging true yung letter C?
You just use your calculator. So this is the x value, and then this is the y. This is the y value. I think this is true. Chinek ko na rin to eh. So we have,
Basta po ba equivalent to 1?
yeah, as long as the result is equal to 1. Okay, so just verify this one using your calculator. Okay. Any other concerns? Okay, so I think that's it. So if you guys don't have a question anymore, then goodbye and thank you guys for coming. Keep safe, and just in case that you have a question, so feel free to message me anytime. Okay.
Goodbye,
Bye,
sir.
Thank you,
Thank
sir.
you po.
Goodbye and thank you.
Bye-bye.
Goodbye. Goodbye to Mr. Chris. Ayan. Okay. What about you, Mr. Bukang and Mr. Kyla Marhes?
Answer, goodbye.
Okay, goodbye. Okay, Miss Kyla, I think maybe she's not around or you're not around. Okay, goodbye. And let's just meet again next meeting.